In this video, we're just going to quickly talk about some more series, talking about converge, diverge. I may not do all the work necessary maybe to show all these things, but I'm going to try and just give you some ideas. Okay, so let's start with this first one. We have an alternating series. You can see that with this -1 to the nth power. What I usually start with then is simply saying, you know, is the limit of this, of what's in red, is that equal to 0? Okay, it is. Factorial is much more powerful than an exponential, and we've seen that through ratio tests. So the answer is 0. So it does converge. All right, and if you need some review on ratio tests, I would urge you to go back and watch a video on ratio tests. For the sake of time here, I'm maybe not going to do all of that. Okay. Now the next thing I would kind of think about is. The next thing to think about is if I dropped the alternating piece, if I didn't have that -1 there, and if I simply was looking at this sequence, 4 to the n over n factorial, the question is, does that converge? Well, by ratio test, it does. Remember, ratio test says you take the next term, divide it by the previous term. I'm going to multiply by the reciprocal, and you find the limit. And the limit is 0 in this case because this will go with this, and factorial, it'll be 4 over n plus 1, the limit's 0. So without the alternating part, without that -1, if you ignore that, the series would converge anyways. Well, that means that this series converges absolutely, because it would converge even without the -1 to the nth power. All right, next. This is a number raised to the nth power, so this is a geometric series. I'm just going to make a little note here above it that this is geometric. 2 times e is 5 point something, or divided by pi. Well, 5 point something divided by 3 point something is greater than 1, so this would diverge, be a divergent test. All right, next. Again, we have an alternating series, so we start by just looking at this. Just look at this and say, is the limit as n goes to infinity 0? Of course, the answer would be yes. It would be 0, that limit. So at this point, I know that it converges, but I need to decide whether it's an absolute or a conditional convergence. Okay, so then I would rewrite up here, maybe in your scratch paper, this series, and focus on it without the alternating piece. Now this would actually be a great time to use the integral test, right? 2 over n natural log n, and we're going from 1 to infinity. Of course, we should rewrite it as a limit as b goes to infinity. But if you did this improper integral, and you'd have to do it by substitution, where u is natural log and du was 1 over n, what you're going to find out is that it actually diverges. Okay? This integral has an area of infinity because you end up with 2 over u. The antiderivative is 2 natural log of u, so it's the natural log of the natural log, and that actually has an area of infinity. So what you find out is that it doesn't converge. This series here does not converge. So you need this alternating piece to make it converge, which means it converges, but only conditionally. All right, next. 4 over n, focus on this. Think, does the limit as n goes to infinity equals 0? The answer is yes, 4 over n, so it converges. Now, we need to focus on the series by itself. Just say, well, if it was just 4 over n without the alternating piece, well, this is a divergent p series. So the only reason we can say it converges is because it was alternating. So again, this converges conditionally. Okay. 1 over n cubed times n to the square root of n. Imagine if I can get rid of that it's to the 1/2. So n cubed times n to the 1/2 is n to the 7/2 or 3.5. So that power is greater than 1. So this is a convergent, and it's by the p series that it converges. Okay. And next, we have again an alternating series. So we focus first on the thing inside here, and we say what's the limit as n goes to infinity. Well, the higher power is on top, so the limit's infinity. So this thing diverges. Remember, an alternating series is the only one where you can start off by just looking at it without the alternating and say is the limit equals 0. If it does, then we say it converges, but then we have to actually check the series without the alternating part to decide if it's conditional or absolute. But this one, with the end of the fourth on top, we can't even get a limit of 0, so the whole thing diverges.